Alright, so in the previous videos I covered how the basic bit stuff that came with the drone worked. So essentially how to set it up, how to do the pairing, and then how to drive it and everything. So now I'm going to show what I added in order to make it autonomous. So autonomous, I added my code to that same thing just to make things easier on myself and anybody's trying it. So I make it so that on a flip of a switch I can both control and the robot with the joysticks, or if I flip it, it goes into autonomous. Um, so this thing right here we actually don't need. So as I said, I added it to the existing code that I showed in the other videos. So I'm gonna show like where I added them and what I added. So the first thing is I have this time update. We're gonna be using this in order to keep track of how much time has passed. This is just to move on between stages that I call them. So going up, going forward, landing, and so on. But in actuality, each state is actually divided more. So going up actually has two stages. It's going up uh, with a lot of throttle, and then decreasing that throttle so it stops rising. So the stages just means it's moving between those changes into the positions in the like to throttle, pitch, and yaw and roll. Um, Dead switch is basically what I use. It's a potentiometer, and then if it's below a certain number, it's gonna be in joystick controller. If it's above a certain number, it's gonna be autonomous. Pretty simple. Now, I connect the dead switch to the last analog pin. That means that the board that I have is completely filled on the analog pins. So if you wanted to add something else, you would have to take something off. Yeah. I don't add anything to pairing. I don't add anything to stop. I do add something to reset yaw. And basically what I'm adding is a time update to check what the current time since the board turned on in milliseconds, and I reset the stage to 1. So every time I press reset yaw, I'm resetting the autonomous code so it works again. I don't put anything in trim set, and I don't put anything here. Now here's what most of the changes are. So in order to change between autonomous and joystick, I have this if statement and this else if statement. If the switch I have is less than 512, it's a potentiometer, so it's all the way to the left, maybe, for example, then I'm going to be in joystick. Now, if it happens that the switch is greater than that, all the way to the right, for example, then I'm going to be in autonomous. So again, this makes it nice for checking whether your drone actually paired correctly or not. You can control the joystick, and it lets you see real time. Okay, it hasn't actually, the connection hasn't actually been established yet, and that way your robot doesn't like suddenly just start flying off the table. This also makes it nice in case the drone kind of lands a little bit far away. If it lands in an area where it's clear, you can drive it back to yourself. So pretty fun. Now the way we're gonna actually look at how the loop is actually doing things. So in essence, wanted to keep the loop is going to be repeating things by itself. It's just the nature of what it is. Now, unlike motors or something, you don't want to just tell the motors to go forward and then delay the program, because we're not directly connected to the drone. We're sending packets to it via the SIGBee. So we want to make sure that we are able to send those packets at constant intervals, like we do right here. So every time it loops, it checks an interval and it sends the packet. If we delayed, we would cause an issue where we're not sending packets, and then we could accidentally miss things. So this is where the time update comes into play. So again, there's different stages. Basically, a stage constitutes when I change what one component or one of the joystick possibilities changes. So here I'm making throttle 80, but in stage 2 I'm making throttle 0 to stop the climb. Stage 3 I change throttle back to a number, but I also change pitch, and so on. So each stage has different values for all the components, and I want to make sure that I do the changes. So that's just what I mean by stage. So inside each if statement, I do a change to the values of these 4 things, possible things, and then I do a check. And this is just to make sure that it's basically doing this action for this amount of time. So this is milliseconds. So this is 1 second of the throttle increase going to 80. Once it reaches 1 second, I reset my update and I move on to stage 2, and I do the same thing again. I change the throttle. I am constantly checking whether a second has passed. If it has passed, I update the time update and I change to stage 3, and I keep going with that. So what this is doing is, as the loop is repeating, I am not stopping at this particular spot unnecessarily. I'm not stuck in this point. And so at the end of all these statements, every time I send a packet, I send what I want my drone to be doing. And so this keeps my drone constantly checking sensors and constantly checking things, and it doesn't bog it down in any one spot, right? So these come from playing around with the drone. So if you want your drone to do different things, you gotta play with the numbers. So in essence, what I'm telling the drone right here to do is I'm telling it, hey, you're gonna go with throttle 80. So ideally this would just make it go up, and then it's gonna do this for 1 second. Once a second happens, it's gonna move on to stage 2, and it's gonna turn off the throttle to keep it from climbing any longer. But then it's gonna, the way the drone works is you don't necessarily, once you tell the robot to start spinning the motors, doesn't turn them off. So just because you put throttle 0, it doesn't mean that the drone's gonna start dropping immediately. So this is just to kind of stabilize the robot for a second. Once it's stable, I move on to stage 3, which is I again put throttle on, and then I move it a pitch so that it starts going forward. From playing around with it, what I noticed is that if you keep the throttle at a specific point, it keeps climbing and it creates issues. But when you turn it off and on and off and on, it creates a situation where the drone kind of jumps a little bit, but it's more stable. I tried doing things where like I decrease the throttle to a really small number where like technically the motors would still have some strength to them, but it wasn't making much difference. And then it was affecting when whether I had a full battery or not. So later on, when there's sensors to play with, this is going to look slightly different. This infrastructure too can be used for when there's sensors, because again, you're not stuck here doing stuff, and so you're constantly checking sensors to see what they're saying. Back to what I said the drone's actually doing. Stage 3, I increase the throttle again, it goes forward, and then it does this for a very small amount of time. This is more for the throttle than for the pitch. The pitch is still going to continue going forward. After this stage 4, I turn off the throttle again. I keep the pitch because I'm still going in the forward, and this time we're doing it for 400 milliseconds. Again, not a lot of time between actions. This code is basically gonna make the robot go a short amount of time or short amount of distance, and then try to land. Here I increase the throttle, I increase pitch, and then the particular zone I was trying to land on was a little bit to the side, and I kept the robot kept veering to one side, so I increased the roll so that it would turn to the left. I decreased the pitch just so that it would slow down its forward movement, but not completely stop it for half a second again. And then stage 6, I turn all the values to 0. So here it should start going down, and I do this for a very long amount of time. So this is essentially the beginning of your descent or your landing. Once stage 6 is done, we move to stage 7. Throttle doesn't turn off the motors. So once the motors turn on and your program starts, even with joystick, they won't stop unless they crash or something happens. So, but putting a negative number makes the robot drop faster, slows them down considerably. So here I put after I already turned the throttle off for a while, for a second and a half, I decreased the throttle to -0, 100, because by this point I'm assuming that the robot already pretty close to the floor and it just needs to travel a little longer. And then pitch, I'm trying to keep at 0. It's already at 0, but it's just a redundancy. I do this for 1 second, and then I move to this stage, stage 8. Now stage 8 it looks different because again, throttle, messing with the numbers in throttle never actually stops the motors. So if you actually want to land, you have to send stop to the drone. And so this is exactly the same as the code up here for stop, except that I'm calling it down here. And this is just so that it ends. And then I changed the stage to 9 just so that it's not constantly staying here, just a precaution. Now, all the if statements are not tied to each other because there's no need. Stage is already doing that for me. So I don't need to make this an else if, because even if stage is the one I'm checking and I'm increasing stage. However, this statement that sends the packets to the drone is outside of it, and this is just so that I can constantly be sending, again, not stuck at any one spot. With the drone, because they're not connected directly and it's trying to kind of catch what we're sending per se, we want to send as many packets as we can to make sure that at least one of them is bound to get to it per interval. So that ends us to, that's the end of as to how the autonomous portion works. And then again, this is kind of changed. So once we're able to shoot missiles, so we figure out how to do that, we can add that logic into here, kind of like we do here with the throttle and everything. Since it's just packets, we can just say here like the missile packet, and it's just another stage. The other thing that in the future we can do is receiving information from the drone, and what that would mean is that the way here we're looking in time, we can also check here for stuff. For example, if the battery life is getting too low, we can adjust throttle so that it's higher, so that we can actually fly at a similar level than we already are. And then if the battery is really full, that means the motors are actually spinning pretty well, and then we can just decrease the throttle so that we're not wasting battery. And it's each run of the autonomous code is similar to the other. As it is right now, full battery, the robot likes to climb a lot higher than it needs to, and then as the battery lowers and it runs out of it, the drone has harder time getting to its destination. So yeah, that's the end of this tutorial on autonomous. Thank you.